Well, while everybody's coming in, I always start with Dilbert's, just because for some reason he seems to describe my programming better than anything else in meetings I'm in. And for this, I thought that the far left bottom corner was right when he said, what are the terms of blockchain? And he said, only the goofy ones, token, smart contract, certainty as a service, UTXO, etc. So what we're here to talk about today is how blockchains are no longer monolithic programs, and they're changing very rapidly. And they're going to become more of a composite application over time. So I'm James Berry. I'm the CTO and co-founder of Taekion, and Bill Katsak, who's our chief architect. Just a bit about Taekion. We're a 4-person company surviving on U.S. government grants. We've got a grant from the Department of Energy, one from the U.S. Air Force, and one that's probably more relevant to this particular session. We have one from the National Science Foundation to create an asynchronous, fault-tolerant consensus mechanism. So as we're going through this, we're going to talk, I'm going to kind of give the setup about where I see blockchains and the fact that they're not really composable apps today. Bill's going to get into what we've been doing with them and where we see Hyperledger as having some places it could improve and ways that you can use Hyperledger to build a more composable app yourself. And I'll leave it with talking about some possible new areas that we could launch different projects within Hyperledger to really build up a blockchain that's not necessarily a monolithic blockchain. So, I guess, oh, there it goes. A lot of discussions come out in the last year as whether blockchain as an application is meaningless, or is it a design pattern? We've taken the approach that it's more of a design pattern than it is a monolithic application. The monolithic application requires you to actually use all the parts of it. So what we're going to cover in the next 30 minutes is, can your blockchain adapt by workload? Should they be a monolithic one or a new way of programming? You know, what does Hyperledger functionality stack look like today? How are we, Taekion, using different components to build out our app? What shared components are missing from Hyperledger? And lastly, you know, why not use new apps from the existing DLT community? And why Hyperledger can be the Apache.org of the blockchain community. So if you configure by workload, is one size fits all good for blockchain? If you think about Fabric, you think about Sawtooth, you think about any of the blockchains we have, or Ethereum, it's generally a one-size-fits-all. You get one blockchain and you try to figure out how to scale it. You know, if you're on a public network and you're seeking a worldwide audience, you really need an irrevocable transaction for cryptocurrency. But if you're a public network serving a small group, like real estate, title, you still need that irrevocable consensus, but it's low volume from a TPS standpoint. TPS being transactions per second. If you look at private networks between companies like supply chain, it's usually a low TPS, stringent need for consensus. Private between subsidiaries is accounting settlements and stuff is low TPS, still a stringent need. Network within a company, low TPS, less stringent, and least of all, is private networks for mass product. There's a bunch of gaming companies that are throwing the results in for 24 hours into a blockchain and then they blow it away. That way you make sure that you're not cheating. So those are some different ways you can look at workload from a workload perspective. You know, standard monolithic software is user interface, business logic, data interface, blockchain, or a database at the end of it. When you get to what we have been doing is you take that standard components and you break it out to microservices. So you have microservices style components, and I'll take you into, or Bill will take you into how we're using the Hyperledger pieces, and I'll take you into some areas that either us or other people are working on to expand that within Hyperledger. And one thing I want you to think about is, I've been around for a while. I was early on in HTTP. XMPP I took to the IETF, which is messaging. And I think that we're kind of in that third major step of my lifetime. Amazon, Facebook, Google, Twitter, they all built themselves off Apache. What wasn't there, they put into Apache. If you really look at their stack and you read their blogs from 10, 15 years ago, they used the Apache stack to launch very quickly. They were less of a technology company than they were trying to assemble the pieces and make something happen. And that's where I see needing to happen within the blockchain community. But today you're limited. You have Ethereum, you have Fabric, you have a big monolithic application that has everything you need in it, but doesn't allow you to expand out. So when these companies came out, they started putting out things like Kafka and other different applications into Apache. And I'll kind of show you the evolution over time. When I first started out, Netscape, AOL, Prodigy, MSN, CompuServe, eWorld, names you don't hear of anymore, there wasn't an internet. They were private internets. You got on there, you couldn't send your mail from CompuServe to AOL. You couldn't send your mail across. All that interconnection has got to change. If you think today it's hard to send your information from Ethereum to Bitcoin or EOS or Corda or any other app. So what we're all about is trying to break it apart and making it so that you have everything working together. So my last slide on here is, what about a Hyperledger stack? Today you have 4 core blockchains. You have Indy as kind of an immutable identity. And you started to see on the left, as you go down, Transact is starting to be a smart contract interface, the ability to move smart contracts out of the blockchain into its own separate interface. And I'm already starting to see other applications start to look at Transact and trying to adapt it so that they can use Transact as their smart contract interface. Same thing with pluggable encryption. You know, right now Ursa has the security keys, the primitives, etc. Avalon has off-chain trusted execution. So there's a few things that are happening. We're going to cover what's missing in a minute, and they're operational apps. So I'm going to turn it over to Bill, and he's going to talk about what we've been doing.
All right, so I just want to talk a little bit about how we've leveraged Sawtooth and some of the other components of the Hyperledger stack to work on our internal business cases. Unfortunately, we can't talk about what we've actually built with the platform because we're still at that point in our evolution. We can't give away the farm. But essentially, we've started out using Sawtooth, and Sawtooth forms the base of what we're calling our Taekion core platform. We have several core apps, each of them doing actually drastically different things, but some of them, actually a few of them, need to actually share state with each other, and sometimes something that one part of the network does needs to tag some bit of information onto something that another part of the core network does, and that actually works out great with the Sawtooth paradigm because we set up each core app with its own transaction family, and we define what the key information are in each transaction family. And then we have another transaction family that has the sort of things, IDs and things like that might actually need to be shared between them. And some nice features of Sawtooth, like transaction batches, which are atomic, allow us to manipulate state even when they go across transaction families and still think of them as atomic transactions that get committed at exactly the same time or don't get committed at all. Sawtooth gives us a really nice signing and permission facility. It's very powerful. It's simple, but it works very well and gives us sort of a per entity access control as far as what they can update and mutate on the chain. And last but not least, the pluggable consensus is extremely powerful. So we actually have some funding we just received from the National Science Foundation to look at a bunch of different consensus schemes for different type of situations, some of them being war fighting, some of them being more civilian, but we actually have a test framework where we're actually swapping these out on the fly and comparing things across them. And Sawtooth, with its pluggable consensus, has enabled us to do that fairly easily. In addition to the Sawtooth base, we've actually adopted Transact. Now, Transact is in Rust, but it does have some C APIs, and We've been working on Go ports where we need it. We've started to use all of the Transact code for submission and transaction management where possible across our core apps. Where it hasn't been possible, we've gone back to the base from Sawtooth, but we've done it wherever it's possible. And by doing this, we ensure clean, standardized code that sort of is going to work now and it's going to work into the future as our system continues to evolve. One additional thing we've done here that might be of interest to the community is we've been experimenting how to add a well-defined SDK to build application clients for and put it into Transact. So for example, you have a transaction family that represents an application that you've built on the blockchain. You have all sorts of internal data, state, things like that that need to be manipulated. And by default, if you roll out something like this in Sawtooth, your client code has to be written sort of ad hoc. You need to build sort of stubs in your programming language and sign your transactions and submit them and follow up on them to make sure they're committed. And you have to do all this stuff. It's actually a huge amount of boilerplate code that needs to be done for that. So one of the things we've actually done, and we've already put it out there as open source to the community if anybody's interested in Golang, is we've actually developed an application client SDK that follows sort of what we call an API builder paradigm. You sort of define methods in it, you define functionality, you define state that goes in and out, and you just get a library that you can instantiate in Go, give it the address of a Sawtooth system, and then just start using it like any other software library. And it actually is very nice, and we're using it across our whole stack right now. If you're interested, you can check it out at that URL. So sorry for the shameless plug. We're hoping people will look at it and start using it. We are planning to roll this back into Transact, and in fact, we have a bunch of Transact code that we ported to Golang that we are sort of preparing to push back upstream. Ursa. We really like Ursa now. Some of you may have been at the Ursa talk earlier. Ursa really hasn't reinvented any wheels. It just made the wheel sort of consistently round. So you can use, wherever you use it, you get a well-defined interface, and it behaves as you would expect it to. The reason we adopted Ursa instead of using Golang crypto code or OpenSSL is that some of our clients have very specific cryptography requirements, in particular the DoD. They require that you put their stuff in, and that's it. It's not up for negotiation. It's not up for discussion. You have to put their stuff in. But most other clients don't really need that level of stuff, or they don't have that sort of a specificity in their requirements. So we needed to be very careful as we were designing our system to completely abstract anything that was crypto into sort of very discrete packages that could be brought in and brought out as needed. And we found that Ursa was a really great layer in which to do this abstraction. We write for Ursa. If we need to expand something, add something, we can add it in using the actual Ursa API, and we don't have to worry too much about how it's interfaced to. So that being said, I've talked about what we really like in Hyperledger, what we've been able to leverage and get benefit out of. So the second part here is what we think needs to be done in Hyperledger and what we actually are trying to contribute to in the future, and hopefully the relatively near future. The first thing, especially tying into our NSF grant, is a really, really pluggable consensus. So a bunch of different components claim that they have pluggable consensus right now. Sawtooth and Fabric in particular both have pluggable consensus, but they're not compatible with each other, okay? So you can't implement a consensus algorithm on Fabric and then go ahead and use it on Sawtooth. It just doesn't work. We believe that Hyperledger needs a well-defined standard for this and an interface, a standard and an interface for pluggable consensus. The main reason for this is that implementing a correct, robust version of one of these algorithms is hard. It's not a trivial exercise. It never has, and I don't think it ever will be. You don't want to do this more than once. What you really want to do is implement PBFT, debug it, test it, stress test it, and put it into production, and be able to trust that you can use it in whichever platform you're going to use, whichever sort of blockchain system you're going to end up using. And that's what we'd like to do. The second thing, this is some people have been debating with me about this, but we believe that it would be nice to have a common networking and connection management library. So Sawtooth uses 0MQ sockets, which are really nice. It's a nice extension of the very basic socket API, but it's still too low level. We're working on a system that gives a sort of a modularized version of the standard common communication schemes: peering and discovery, gossiping, reliable connection management, and sort of a few other things that we've needed, and we're planning to push it out as an independent library. In particular, we've been working on a bug in Sawtooth's connection management that sort of catalyzed this. The next thing is abstracted block storage. All current blockchains assume a replica of every block on every node. And this is sort of an assumption that's been with us for a while. It's been with us pretty much since the beginning. But what we're finding in talking to people in the business world is that not all use cases need this. If you have a 10-node system across 3 different locations for consensus and sort of validation reasons, you don't need 10 copies of every piece of data. And a lot of people don't want to do this because they don't want to pay for the storage. I don't know if anybody else is hearing this, but we've heard this a lot. We believe that block storage, even inside a blockchain system, should be an abstraction. It should be decoupled from the validation. It should be decoupled from the consensus. And it should allow for custom storage and replication strategies. So for example, if I have a 30-node chain, I may set every block to a replication factor of 3, a la Cassandra or something like that, and the system will guarantee that we have 3 copies, but we don't need to do full replication across all of those nodes. And once this is in place, and once this is nicely abstracted out, you could start doing fancy stuff. You could use existing object stores. You could do fancy schemes like erasure coding and things like that. I think this could be a really interesting place to go with this. Another one is key storage. Key storage is a relatively solved problem. People know how to write key stores, but so far there's no official Hyperledger standard. We had to do something with this very early for the DoD clients to satisfy them that we were storing the keys properly. And I could see this being either standalone or with Ursa. Now, I made this slide earlier, but as I was speaking to people today, it was brought to my attention that Ares is planning to do this. I checked right before the talk, and the Ares GitHub mentions that this is coming soon. So this point may be obviated already, and it may already be a done thing. But that's actually okay, because it just means that we really did have a problem that we identified and people are fixing. And the last thing that I would like to see standardized is a sort of a fixed or standardized API for data exporting. Sawtooth has a system called state delta exports, where you can subscribe to the blockchain and subscribe to a validator and get a notification every time the state changes. And this is done in a few example applications. So for example, the Sawtooth supply chain example stands a database alongside the blockchain and uses this state delta service to keep a up-to-date copy of the blockchain state in the database in order to support things like more complex queries or deal with a larger amount of load as far as looking at data. But this is a Sawtooth specific thing. They just sort of implemented a protocol over ZMQ using protobufs, and it's their internal thing. It works very well, but it needs to be standardized so that if you have an application that has been developed to take this kind of sort of state delta, you shouldn't have to re-implement that tie if you move from system to system or if you reorganize your system. So I would like to see a standardized format, or at least a standardized interface or a definition language for defining this type of stuff. So with that, I'll give it back to James.
So taking all of that put together, this is kind of a slide showing what's there today and what we think needs to be coming out in the future. And frankly, if you look at the state of internet applications and you go to a place like Apache, you can find everything you need in order to build an application from start to finish. You don't have to get a generic, you don't have to get a generic blockchain and then try to work the edges around it. You can get the pieces you need for your workload. So we're going to make a lot of these proposals. We are 4 people, so we're not like this huge, massive organization like IBM. or other large organizations in there. But we think that these should be standalone projects. You should be able to link them all together, and there are a lot of advantages to doing that. And this is taking a pattern that has happened time and time again for the last 50 years in software, which is it starts off with a monolithic system and it breaks apart. I know I started off in Java Enterprise Edition. We started making that more and more discrete components until basically you don't want to use J2EE because it got too complex, and then everybody started making very standalone components that you could now build real applications with. So if you take this, we talked about block storage being probably the primary thing that nobody in blockchains is thinking about today. Block archiving, there's a labs product out there, but nobody seems to be committing to it. There's key storage, pluggable consensus, and I actually have something on another slide, but while it's up there with all of these on, Enterprise Ethereum, Fabric, and Sawtooth. If you just took those three, they're all open source programs. They've all implemented a way to do pluggable consensus, and they've all not abstracted it out so that it can be used between programs. So if you are a consensus writer doing PBFT, and I just use that one because that's practical Byzantine fault tolerance for those who haven't heard of it. A lot of universities, for some reason, seem to put their masters and PhD people on it and write yet another PBFT consensus. You should be able to plug it in, make it work, and show people how it works very quickly. And wouldn't it be great if it was a shared library? The network and connection management layer, really this is the communications, gossip, all that kind of stuff, really can be brought down to a layer that it's an in and out area. There's no facade for business logic. If you think about it, as you're writing business logic, you really want something that glues onto your blockchain and you can use it. I've had 3 or 4 people at this show tell me that their team is actually writing basically a standard centralized app, and then they just reference blockchain off of it. Wouldn't it be better if it was an exposed set of endpoints that you could access and make it into a real distributed application as opposed to a centralized application? I mean, even in the blockchain top 50 coins, if you look at those, 11 of them are fully standard, or I would say not distributed whatsoever, even though they call themselves a blockchain, and I can take you through that privately if you want. One that everybody knows about is IOTA, which collapsed because of their central coordinator and was down for 2 weeks. So there are a lot of centralized applications masquerading around. This would, having a facade for business logic allows you to build it and actually have a real distributed application. We talked about data exporting, data importing, having a way to do what they call Oracle support. I love the way all the names are different now, but the functions are the same they were 10, 15, 20 years ago. There is no access control to a corporate ID. When I say that, you know, LDAP is how everybody stores their IDs, right? Except it's called Active Directory for 99% of the big companies. Why don't we have a standardized way of dragging that and putting that access in? Membership services governance. So those are some ideas, but if you take all these together, do you need a Fabric or a Sawtooth, an Iroa, or Burrow? I don't think so. I think you'd be able to assemble your own and be able to do the distributed properties yourself. And so I threw one slide in here real quick. What about layer 2, layer 3, side chains, state channels, all of that stuff? The thing about those is almost in entirety, they are a separate app sitting in the cloud that you access. So you're giving your data up over the cloud. They have a separate API, separate network connections, transform data. So no longer are you in a blockchain that's shared between companies. It's not only the company you're sharing it, but the company supporting it. So if your blockchain doesn't support some function and now you're doing a layer 2 app or a layer 3 app, now you're reaching outside of your own circle of blockchains. If you've got 5 companies, now you've got to have things in there like compliance, SOX, and PCI if you're with a big company are important. Everybody who deals in that has to have that. Most of the small companies don't. So if you have components, a lot of times you can get by and get the function you need without having to go to an outside company. And there's no weird cyber currencies involved in transacting. For example, there's one major blockchain that has consensus as a service, except you have to pay them in their chain. And I've talked to several companies talking about, well, I have to go to my accounting department, have to allocate out, $100,000, sit in an account, buy this particular cyber currency, have it sit there until it's drawn down as we use it, and then get another 100,000, and the accounting for that is a nightmare, and that alone killed the project. He was trying to figure out how to get all of this to happen. So if the components come out and this works, I think personally that would really make the blockchain community go faster. And I already talked about, Fabric, Sawtooth, and Enterprise Ethereum all having a consensus library. So today, Hyperledger Greenhouse has all of these applications, and you've seen that little house around. I think Hyperledger needs to be the Apache project list on the right. When I started with Apache, it had been around for a little while, and it had one project. Met Brian. We had HTTP. I brought some Java in. We suddenly had two projects. I was with a company called IBM at the time, so we ended up having to write the Apache 2.0 license for the Apache guys, because as the blockchain guys are today, they were the young kids then, and we were the old guys. So we made that so you could have all of the different functionality that you need. So that's why Apache has gotten so big. There's a lot of functionality you cannot envision inside of our product. And the more you start putting onto a generic blockchain, the bigger it gets, the harder it is to work with. So suddenly, do you interface that by having a weird coin transaction, or do you have a piece that you can now import in a library that you can use? So that's kind of how we envision where Hyperledger go. We're using that today. I mean, we use Sawtooth only because we immediately were able to break apart our application easier into components faster. Not to say that there aren't reasons we maybe should have used Fabric or whatever, but we chose Sawtooth. We're using Transact. We're using Ursa. We don't do coins, so we don't do Quilt. We're looking at areas. All these are ways that you can start building a blockchain from the ground up. I don't think you're going to end up needing to have a Fabric, a Sawtooth, or any of the other ones as themselves. I think you're going to end up having components that you'll build like you do standard applications. And this is for private chains. This is not talking about a public chain and that type of stuff. So do we have any questions? I always end with a Dilbert, like I started with a Dilbert. Any questions on what we're doing or how we're doing it?
I'd like to just make a comment before we take questions, is that we've got up here and sort of we've been preaching about all these things that should be. And I want to make it clear that almost everything we've proposed here, we've already started working on in some form internally. This is actually not something that we're just guessing about. We're saying, oh, it should be there. It's something that we've already, all of them are things that we've concretely started working on. We don't have a lot of manpower to be polishing these things up into nicely packaged projects and getting them out there for consumption. That's something that we want to get to. And if anybody is interested in anything that we've mentioned, we'd be more than happy to sync up with you and maybe try to formalize it and get things out there and share what we've already done regarding it. The only thing that we've been able to push out so far is the client SDK, which was a pretty big effort to get the time together to push it out. So I just wanted to make it clear that we're not trying to be up here and be preachy and trying to say this is what you guys need to do. We're doing it. We're doing it to the best of our ability with the resources that we have, and we'd like to do more. So.
And as you'll find out with an open source project, there need to be a lot of hands in it. The reason, and we're big open source advocates, so we'll open any of our code up that people have. We just don't want to open it up and have lots of questions that deter us from building our regular application. So if anybody is interested in any of those up there, we'd love to talk to you.
Any questions?
Any questions? Thoughts?
Yeah, so more a thought than a question, but I think the breakdown you gave with new projects and what Hyperledger should be looking at is actually really helpful for the steering committee.
Are you on the steering committee?
As it happens, I'm on the steering committee.
That's good. So I was asked to repeat the question or comment, and his comment was that diagram showing what should be there, or our thoughts of what should be there in the future would be helpful for the Hyperledger Steering Committee, and he is on the steering committee.
I ran for the steering committee this time around, didn't make it.
Try again next year.
Absolutely.
Any other thoughts or questions? I think we're out of time at this point. We had 30 minutes, so we tried to condense down something where we would have shown a little bit more. Hopefully it was educational for everybody, so thank you.